Good morning, dear students. So, last class we studied about orbital, difference between orbit and orbital, shape of orbitals, and quantum number. Among the quantum number, there are four types of quantum number, but we discussed about principal quantum number and azimuthal quantum number. Here we are going to discuss now magnetic quantum number and spin quantum number. So let's come to magnetic quantum number. It is represented by letter M and given by scientist Linde. Actually, we know when atom radiates some energy and that analyzed in a spectrophotometer, it gives spectrum. And when these spectrums are again analyzed on application of electric field and magnetic field, it is found that these lines again splits into different lines. That means suppose in ordinary condition it seems one line, and when applied electric field and magnetic field it is shown that this is consist of 5 lines or 4 lines or 3 lines like this. So in this way how this splitting takes place. So that means if it is present in cell and subcell, then how this splitting takes place? If the electron goes remain in the same subcell, in the same cell, then how this transition takes place, how this electron transition takes place, and how the spectrum forms different lines. That cannot be explained. So in this way it concluded that the subcells are again divided into some other parts. So the subcells are again divided into orbitals. Okay, so cell divided into subcells and subcell again divided into orbitals. That is called the orientations of electron cloud, the orientation of orbital or the orientation of electron cloud. So this quantum number describes the orientation, that is means alignment, how these are aligned, the orientations or the alignments of electron clouds in a subcell. So it is related with azimuthal quantum number by the relation m equal to minus L to plus L through 0. Minus L to plus L through 0. Okay, and for a particular value of L, there are 2L plus 1 number of M values. In this way, it determines how many orbitals are present in a subcell. For example, when L value is 0, M value is also 0. And when L value equal to 1, M value minus L to plus L, minus 1, 0 and plus 1. And how many number of values? 2L plus 1 number of values. So 2 into 1 plus 1, that is 3 values. So for L equal to 1, there are 3 values of M, and these 3 values are minus 1, 0 and plus 1. And again, when L equal to 2, then what are the values of M? The values of M are minus 2, minus 1, 0, plus 1, plus 2. And how many values? 2 into 2 plus 1. That is equal to 5 values. And these 5 values are minus 2, minus 1, 0, plus 1, plus 2. And again, when L equal to 3, M equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So how many values? The values are 2 into 3 plus 1, that is 7 values. And these values are minus 3 to plus 3. So for a particular value of L, there are 2L plus 1 number of M values, and these values are minus L to plus L. And this describes how many number of orbitals present in a cell, in a subcell. When L equal to 0, what is that subcell? That subcell is S subcell. That means now this F subcell, so when M equal to 0, that means it has only one value, 2 into 0 plus 1, that is equal to 1 value. So this S subcell consists of only one orbital. Only one orbital. बुझिए? Similarly, when L equal to 1, that is P subcell. So P subcell, S subcell, that is P subcell. So L equal to 1. L equal to 1 means M minus 1, 0 plus 1. So it has 3 values. So when L equal to 1, that subcell is P. So P subcell classified into 3 orbitals. So as it has 3 values, this is of 3 orbitals. And these 3 orbitals are Px, Py, Pz. Px, Py and Pz. Already we have discussed in last class. And again, when L equal to 2, what is the subcell? That subcell is D subcell. And the D subcell, M value minus 2, minus 1, 0, plus 1, plus 3. How many values? 5 values. That means this D subcell has 5 orbitals. So it has 5 values. That means 5 orbitals. So one subcell classified into how many orbitals? And what are the orbitals? dxy, dyz, dzx, dx square minus y square, and dz square. 5 orbitals. And again, when L equal to 3, what is that subcell? That is F subcell. So F subcell has F subcell, and how many orbitals? 7. So it has 7 orbitals. So it has 7 values. That means it has 7 orbitals. And it has very complex structure like Fxq, Fyq, Fzq, Fx and Fy. So different types of orbitals are there. So look here, note down this magnetic quantum number. It was given by Linde, denoted by letter M. So this quantum number describes the presence of electron in an orbital and also the orientation of electron cloud, the orientation of this subcell. So it is related with azimuthal quantum number by the relation M equal to minus L to plus L through 0. For a particular value of L, there are 2L plus 1 number of M values, and an orbital can accommodate maximum of 2 electrons. All these informations generally we get from magnetic quantum number. So for S, when L equal to 0, we know that M equal to 0, it has 1 value according to 2 into 1 plus 2 into 0 plus 1, that is 1. And in this S subcell, it consists of only one orbital, that is S orbital. And when P subcell, L equal to 1, M equal to minus 1, 0 and plus 1. So it has 3 values, and that is we can know from 2 into 1 plus 1, that is 3. In this way, P subcell, it consists of 3 orbitals. 3 orbitals, that is 1 orbital, that is S orbital, and 3 orbitals, that is Px, Py and Pz. Similarly for this subcell L equal to 2, that is M equal to -2, -1, 0, +1, +2. It has 5 values according to 2 into 2 plus 1, that is equal to 5. So it has this subcell consists of 5 orbitals, and the 5 orbitals are dxy, dyz, dzx, dx square minus y square and dz square. Similarly, f subcell L equal to 3, then M equal to -3, -2, -1, 0, +1, +2 and +3, and it has 7 values, and these 7 values we know that is from 2 into 3 plus 1, 7. So it has also F subcell also consists of 7 orbitals. In this way, electron present in which orbital, that is given by this magnetic quantum number. Just note down this. Okay, so this is about magnetic quantum number. Next come to another type of quantum number, that is spin quantum number. So this principal quantum number, azimuthal quantum number and magnetic quantum number all have integral values, that is all have integers. But the spin quantum number, this is different. So all these are related with each other. Magnetic quantum number related to azimuthal quantum number, azimuthal quantum number related to principal quantum number. But the spin quantum number, that one is independent. Okay, the spin quantum number represented by letter S. So when electron moves in orbital, in a cell or in subcell, electron present, so it moves it around the nucleus in subcells or cells, but itself electron moves around itself also. So suppose this is cylindrical, suppose this is a spherical, we can say this is a spherical, so it has some axis. So electron moves around itself either in this direction or in this direction, just as a ball spins, just as the cricket ball spins either in clockwise direction and anti-clockwise direction. So an electron not only moves around the nucleus, it also moves around itself on its own axis. So in this moving, either move along x-axis, either in clockwise direction or in anti-clockwise direction. So this movement is generally represented by either up arrow or down arrow and by a number, that is plus half and minus half. So if it is clockwise, generally represented as plus half, and for anti-clockwise represented as minus half. And for this clockwise, generally up arrow, and for anti-clockwise generally represented minus half, or say down arrow. So the spin quantum number that represents the spinning of electron, it has only two values, that is plus half and minus half. In this way, this spin quantum number also represents the spin angular momentum, and it also describes the magnetic moment or magnetic character of matter. If any orbital contains these two electrons, then one has plus half value and another has minus half value. In this way, these electrons are paired. And these are generally diamagnetic in nature. So the magnetic moment created by one electron due to spinning is cancelled by the magnetic moment created by another electron. But if the single electrons are present, then they have some net magnetic moment. So the magnetic vector is generally described by this spin quantum number, and this spin quantum number is generally given by Goldsmith. So it represents the spinning of electron. The spinning of electron. So this describes the spinning of electron. So an electron not only moves around the nucleus, it also moves around its own axis, around itself. That is either own axis around itself, that is either in a clockwise direction or in anti-clockwise direction. And what are the points of this spin quantum number? Note down, just note down. So note down these points. Spin quantum number, it was proposed by Goldsmith and represented by letter S. It gives the spinning of electron around the nucleus, around its own axis, spinning of electron around its own axis. As spinning can take place in two ways, clockwise or anti-clockwise. So in this way it has two values, that is plus half and minus half. These two values are normally represented by two arrows, that is pointing opposite direction, one spin upside, another downside, that is spin down. And this quantum number also leads to spin angular momentum, that is represented as ms, or ms equal to s into s plus 1 h by 2 pi. So these are some informations given by spin quantum number. So from this we can also know that an orbital can accommodate maximum of 2 electrons. One has plus of value, another has minus of spin value. Okay, so these are about quantum numbers. So there are 4 types of quantum number which describes about the energy, about the soft shell, about the orientation, about the spinning of electrons. So from above, what we conclude? From above, we conclude that if n is the principal quantum number, then what information all total we get? So you can find out the energy, you can find out the radius, you can find out what are the soft shells present and what are the orbitals and what is the spin of electron. All these informations generally we get from these quantum numbers. So if the principal quantum number is n, then how many soft shells are present? If the principal quantum number is n, then the number of soft cells is n. If the principal quantum number is n, then the number of soft cell is n and number of orbital is n square and number of electron is 2n square. Similarly, if the soft cell is given L, then how many number of orbitals are there? Then the number of orbitals for this L is 2L plus 1 number of orbitals are there and electrons are 4L plus 2 number of these. Similarly, suppose orbital given, m value is given, suppose an orbital, then one orbital can accommodate maximum of 2 electrons. Okay, so in this way we can get information from these quantum numbers. Suppose one electron has given that one electron is present in third cell. One electron present in third cell. Find out what are the possible values of N, L, M and S. Find out what are the possible values of N, L, M and S. So as this is the third cell given, from that we know this principal quantum number N equal to 3. That is your principal quantum number. That is n equal to 3. as n equal to 3, then what are the possible values of L? So L equal to 0 to n minus 1. That means 0, 1, 2. So there are 3 values of L. So 3 values of L. There are 3 values of L. 3 values of L. And third cell, what are the subcells present? The subcells present are 3S, 3P and 3D. Next, what are the possible values of M? For 0, if for 0 that is 1 value 0, and for L equal to 1 there is also 3 values. For L equal to 0, M equal to 0, and when L equal to 1, then how many values of M? 3 values. And what are -1, 0, +1, and when this is 2, and how many values of M? 5, -2, -1, 0, +1, +2. In this way, when N equal to 3, L equal to 3, and 1, 2, 3, 4, and then 5, 9, n square number of M values. Next, if one of this contain 2 electrons, plus half, minus half, plus half, and minus half, here also plus half, and minus half, plus half, and minus half, plus half, and minus half. In this way, if we consider how many electrons total present, one orbital can accommodate 2. In this way, we can know. So here it contains all total 10, here it contains 6, and here it contains 2. In this way, here all total it contains 18 electrons. Okay, so in this cell classified into subcell classified into orbitals. In the orbitals, electrons are present. So what question is given? If an electron present in third cell, what are the possible values of N, L, M, S? So N value this one, L value this one, M value this one, and S value is either plus or minus. It has only 2 values, which is not related with other quantum numbers. So an electron is present in third cell. The possible values of N, L, and M are this one. So in this way, you can solve different types of problems, and we will discuss later different types of problems. Next, come to another portion, that is Powerless Exclusion Principle. So according to this principle, so Powerless in 1921 studied about all these quantum number, and he concluded that if we consider about any two electron, then no 2 electrons in an atom have all the 4 set of quantum numbers alike. They may have 3 quantum numbers same, but the 4th quantum number must be different. Okay, so according to this principle, no 2 electrons in an atom have all the 4 quantum numbers, same or alike. All the 4 quantum numbers same or alike. That means if we consider about any 2 electron, then they must have maximum 3 quantum numbers same, but the 4th quantum number must be different. Suppose we consider two electrons are taken from a 4s subcell. Suppose two electrons are taken from 4s subcell. Then electron 1 and electron 2, N, L, M and S. So I is taken from 4s. Its N value is 4 and here also 4, and L value as this is S given. Here S represents your this quantum number with subcell. That means this is 0 and this is 0. As L is 0, here M is also 0 and 0. But if the two electrons are there, one must have a plus up and another have minus up. So if another have plus up, then more electrons are present. Suppose plus up. That means there exists some repulsion, magnetic repulsion arises. So for which one have plus up and another have minus up. So due to this, so if both have plus up, then magnetic field created by one repelled by magnetic field created by another one. So repulsion takes place. In this way, one have plus one and another have minus one. So an orbital can accommodate maximum of two electrons. And here we see that N value is same, L value is same, M value is same, but the S value is different. Similarly, if you consider two electrons from 4px and 4py, then it may have same values of this principal quantum number, same value of azimuthal quantum number. It may have, but it have different value of magnetic quantum number. So all the quantum numbers for two electrons are not same. All the four quantum numbers for the two electrons are not same. Maximum three quantum numbers are same, and two electrons, and another, the spin may be different, or in some cases M may be different, but maximum three quantum numbers are same. So this is known as Powerless Principle, and this principle concluded that an orbital can accommodate maximum of two electrons. An orbital can accommodate maximum of two electrons with opposite spin. So as an orbital can accommodate maximum of two electrons, in this way a subcell can accommodate maximum of 4l plus 2 electrons, and a cell can contain maximum of 2n square number of electrons. So it excluded the containing more number of electrons in a cell or subcell or an orbital. That's why this principle is called exclusion principle. That's why this principle is called exclusion principle. Now you note down what are the points. Okay, note down this point. This principle states that no two electrons in an atom can have all the four quantum numbers same or alike. Two electrons present in an atom may have maximum three quantum numbers same, but the fourth quantum number must be different. They may present in the same cell, same subcell, same orbital, but their spin must be different. Let us consider two electrons taken from 4s subcell. So the different quantum numbers for the two electrons are n equal to 4 for both cases, and n equal to 0 for both cases, m equal to 0 for both cases, but the spin value for one this is plus r, for another this is minus r. Okay, so in this way, what we conclude? In this way, from here we conclude that an orbital can accommodate maximum of two electrons. So from this principle, it is concluded that an orbital can accommodate maximum of What is the conclusion? An orbital can accommodate maximum of two electron. And number 2, an subcell can accommodate maximum 4l plus 2 electron. As so 4l plus 2 electron, as and subcell can contain 2l plus 1 number of orbital, and one orbital can contain n 2 number of electrons. In this way, and subcell can accommodate maximum 4l plus 2 electrons. And another, a subcell can accommodate maximum of 4l plus 2 electron, and a cell can accommodate maximum of 2n square electrons. 2 electrons. So as this principle excluded the containing, this principle gives the idea about the maximum number of electrons present in a cell, in a subcell, in an orbital. In this way, this principle is called exclusion principle, because it excluded the containing capacity of electron. It excluded the containing capacity of electrons. In this way, this principle is also called Pauli exclusion principle or exclusion principle. So, in this way you can know how one cell contains how many orbitals, one cell can contain how many number of subcells, and one subcell contain how many number of orbitals and how many electrons present in orbital, cell and subcells. Okay, so next let us discuss some some problematic questions. Let us solve this type of problematic questions. Here I have given only 5. Let us start from question number 5. What are the values of n and l for the following orbitals? So this is given 4d. 4d means this number represents your principal quantum number and this represents your subcell. And from this subcell, we can find out what is your L value. So for 4d, question number 5. For 4d, n equal to 4 and L equal to 2. As 0, if L equal to 0, S 1, then P 2, then D. So D, then L value equal to this one. Then come to B. 5F. 5F means N equal to 5 and L equal to 3. 3P. 3P means N equal to N equal to 3 and P means L equal to 1, and given 2S. In 2S, N equal to 2 and L equal to 0. So in this way you can find out the N and L values from orbitals. Next come to question number 4. Given an electron is present in 4s subcell, write 4s subcell, write the possible values for all quantum numbers. It is already given 4f. So it is given 4f, n equal to 4 and L as F given, L equal to 3. So as L equal to 3, then what are the values of M? No need to write all the values of L, 0, 1, 2, because it is already given 4F. If it is given 4th cell, then you write the L value 0, 1, 2 like this. But only it is given 4F, that means L equal to 3. As L equal to 3, M value minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. 7 values. And what are the S values? That is only 2 value, plus up or minus up. It may clockwise, it may spin clockwise or anti-clockwise. In this way, plus up or minus up. So these are the possible values for electron present in 4F subcell. Okay, it is clear. Next come to question number 3. Using S, P, D notations, describe the orbitals with following quantum numbers. So first question 3A is given n equal to 1, L equal to 0, that means 3S. B, n equal to 2, L equal to 0, that is 2S. N equal to 3, L equal to 1, L equal to 1 piece of cell. So C, 3P. And N equal to 4, L equal to 2, that is 4D. So in this way, you can describe the orbitals from the quantum numbers N and L values. Okay, clear? Next come to question number 2. An atomic orbital has L equal to 3. What are the possible values of M? As it is given L equal to 3, that means M is asked if L equal to 3, then M has 7 values, and the 7 values minus L2 plus L, minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. These are the possible values. An atomic orbital has M equal to 3. What are the possible values of L? So, as N value given 3, so there are 3 L values, and the 3 L values are from 0 to N minus 1, that is L equal to 0 when N equal to 3. Then L equal to 0, 1 and 2. It has 3 values, 0, 1, 2. That means N equal to 3. First cell, that is your M cell. And M cell contains how many subcells? That is 3 subcells. S, P and D subcells. Okay. So in this way you can solve this type of, and next class we will discuss some other problematic questions and also some other portions of this chapter.